Hello everyone, my name is Aiden DiCarlo, and in this video, we'll be diving into the design of my Europa's seismometer. The main mission of this project is to focus on developing aspects of a scientific instrument to be deployed on the surface of Europa, within the ice, or on a submersible under the ice. There were many good candidates, such as spectrometers and chromatographs, when choosing this project. However, I eventually narrowed down on a seismometer as I believe it is a good starting point in determining the environment of Europa. Knowing the seismic activity allows engineers to properly design future deployments that will be capable of enduring such activities. Now, let's first establish what a seismometer is. It is the core sensor located within a seismograph, which detects seismic activity and converts the kinetic energy into electrical signal. This conversion is most often done by using Faraday's law of electromagnetism, taking a conductive material such as copper and inducing a current using a moving magnet. So why do we even bother spend billions of dollars to deploy a seismometer on Europa? Well, there are a few notable reasons for this. First, Europa is speculated to contain the essential backbones of life. Studying the seismic environment of such places is critical in deepening our understanding of extraterrestrial life. Also, it can give us an insight into how suitable life on Europa would be for humans. Additionally, unusual seismic activity on Europa can strongly indicate events on Jupiter. This is because most moonquakes on Europa come from tidal cracking and crevicing due to Jupiter's gravity. Furthermore, smaller seismic activities can be linked to cryovolcanic activities, meteor impacts, and ice-moon interface events. My personal seismometer design will be utilizing the electromagnetic properties discussed previously, where a copper coil will be wrapped around a moving magnet. 3 repelling magnets will be placed within a tube, where the suspended intermediate magnet can be moved by external force. This contraption will be made for 3 perpendicular axes to get vectorial seismic data. An op-amp with 4 individual inputs will be used to conserve space on a breadboard, and a cable connection will be used to gather data on a computer. On Europa's environment, quantum locking, spin-stabilized levitation, and cryogenic liquid or gas dampening are feasible ideas in removing frictional losses. However, this will not be performed on this project for budgeting purposes. This is the rough list of materials that will be used for this project. An ESP32 was chosen as the microcontroller as it is compact and has multiple analog inputs. Additionally, high tolerances in resistors and capacitors were chosen to reduce potential losses. This is the circuit diagram for one axis of the seismometer. It is essentially composed of 3 blocks: a voltage divider, an op-amp, and a bandpass filter. A voltage divider must be used as the induced current ranges from positive to negative values. A negative current will produce negative voltage, and since the inputs of the ESP32 only supports voltages between 0 to 3.3 volts, a voltage bias must be used to offset the initial signal. By using resistors of the same value, the bias is set to half of the ESP32 input, which is 1.65 volts. To stabilize the signal, a capacitor was added in parallel to the grounded resistor of the voltage divider. As for the bandpass filter, it is there to attenuate high-frequency noise produced by electronics or extremely low-frequency non-dynamical vibrations produced by gravity field changes and/or instrument drift. With this information, the full circuit diagram of 3 axes can be drawn as such. The calibration of this device can be done in multiple ways. One way is to use known external forces such as forces produced by shake tables at on-campus laboratories or controlled manual displacement. Additionally, accelerometers can be temporarily used to cross-compare. To adjust for minor calibration discrepancies amongst the 3 axes, the number of coil turns of the copper can be altered. In the end, this project hopes to provide visual vectorial changes in 3 axes with a relatively high accuracy. It is expected to not experience oversaturation due to sufficient dampening, and most importantly, it will function within the expected moonquake frequencies experienced on Europa. This will conclude my design proposal. Thank you.